Let us discuss a few problems on beta gamma functions. The first problem we are going to take up is show that gamma n is equal to integral 0 to 1 logarithm of 1 by y to the power of n minus 1 dy, n greater than 0. How shall we work out the problem? We know that in the definition of the gamma function, there will be a decaying exponential function like e power minus x and then certain power of x. Let us see how we can get it. Log 1 by y, it is nothing but log 1 minus log y. Log 1 to any base is 0. So minus log y you are having. So why can't we use a substitution for it? So we choose or we put logarithm of 1 by y is equal to x, or log 1 minus log y is equal to x, or it is same as saying y is equal to e power minus x. Therefore dy becomes minus e power minus x dx. What about the limit? When y is 0, e power minus x is 0, therefore x should become infinity. When y is equal to 1, e power minus x is 1, so x should become 0. So given integral, that is integral 0 to 1 logarithm of 1 by y to the power of n minus 1 dy becomes integral infinity to 0 x to the power of n minus 1 into minus e power minus x dx, or using the negative sign we can change the limit so that we get integral 0 to infinity e power minus x x to the power of n minus 1 dx, or by definition it is nothing but gamma n. This completes the problem. Another one, express the following in terms of gamma function. Certain integrals will be given to us. We have to express them in terms of gamma functions. The first one under this category is integral 0 to infinity e power minus x square dx. We have to express in terms of gamma functions. This resembles the integral 0 to infinity e power minus x square x to the power of 2n minus 1 dx, which is the definition of the gamma function divided by 2. So by comparison with the integral of the definition of gamma n, we observe that n is equal to 1 by 2. So let us put n is equal to 1 by 2 in the definition we have written. That gives us integral 0 to infinity e power minus x square dx is equal to half of gamma half or half of root pi, because we know that gamma half is equal to root pi. Second method. Alternatively, we can take x square is equal to y. So taking x square is equal to y, x is equal to root pi, or dx is equal to 1 by 2 root y dy. What are the limits? When x is equal to 0, y is equal to 0. When x tends to infinity, y tends to infinity. So given integral becomes integral 0 to infinity e power minus y into 1 by 2 root y dy. Or you can rewrite it as half of integral 0 to infinity e power minus y y to the power minus 1 by 2 dy. Comparing this with the definition of the gamma function, that is integral 0 to infinity e power minus y y to the power of n minus 1 dy is equal to gamma n, we get n is equal to 1 by 2. Therefore, given integral is equal to half of gamma half or root pi divided by 2, since gamma half is equal to root pi. Let us consider another problem, another integral. Integral 0 to infinity root x into e power minus x cube dx. This we have to express in terms of gamma function. So we use the substitution x cube is equal to y, or x is equal to y to the power of 1 by 3. So dx becomes 1 by 3 y to the power minus 2 by 3 dy, and root x becomes square root of y to the power of 1 by 3 or y to the power of 1 by 6. When x is 0, y becomes 0. When x tends to infinity, y tends to infinity. So given integral becomes integral 0 to infinity y to the power of 1 by 6 e power minus y into 1 by 3 y to the power of minus 2 by 3 dy. Simplification gives 1/3 of integral 0 to infinity e power minus y into y to the power minus 1 by 2 dy. A little time ago we have seen that this integral defines gamma half. So it is 1 by 3 into gamma half or root pi divided by 3. We can as well say that by comparing this integral with the integral definition of gamma n, we get n is equal to 1 by 2. Let us discuss one more problem. Integral 0 to infinity x power p minus 1 e power minus kx dx, where k greater than 0. Our idea is to express this integral in terms of gamma function. So, to see that the integral is in the standard form, we use the substitution kx is equal to y, or x is equal to y by k, dx is equal to dy divided by k. When x is 0, y is 0. When x tends to infinity, y also tends to infinity because k is a positive quantity. So given integral becomes integral 0 to infinity y by k to the power p minus 1 into e power minus y into dy divided by k. Taking out k terms outside the integral sign, we get 1 by k to the power p into integral 0 to infinity e power minus y to the power p minus 1 dy, or this becomes gamma p divided by k to the power p. Let's discuss one more integral. Integral 0 to pi by 2 root of cot theta d theta. We want to express this integral in terms of gamma function. Earlier, we learnt one result, that is, we know that integral 0 to pi by 2 sin theta to the power p cos theta to the power of q d theta is equal to half of beta p plus 1 by 2 q plus 1 divided by 2. In the given integral, p is equal to minus 1 by 2 and q is equal to 1 by 2. Or given integral is integral 0 to pi by 2 root of cot theta d theta is equal to integral 0 to pi by 2 sin theta to the power minus half cos theta to the power half d theta, that is p is equal to minus 1 by 2, q is equal to 1 by 2. Therefore, this becomes half of beta 1 by 2 divided by 2, 1 by 2 plus 1 whole divided by 2, or it becomes half of beta 1 by 4 comma 3 by 4. Or expressing in terms of gamma functions, we get half of gamma 1 by 4, gamma 3 by 4 divided by gamma 1. Since gamma 1 is 1, this becomes half of gamma 1 by 4, gamma 3 by 4.